Hey everyone, Mr. Phil's avatar here with another devlog update. Today I'm covering yesterday's work on Stellar Throne, my 4X strategy game. For those new to the channel, Stellar Throne uses a dual-engine architecture, Godot for the UI client, and Zig for the high-performance simulation engine. Yesterday was all about completing the serialization layer that lets these two systems talk to each other efficiently. The main challenge I tackled was implementing bidirectional data conversion between GDScript and Zig. When you're building a hybrid system like this, you need a way to pass complex game state back and forth between languages. That meant creating serialization methods for all 6 core data structures: resources, empire, planet, system, fleet, and galaxy. I implemented a dictionary-based serialization layer where every Zig structure can convert to a GDScript dictionary and back. This sounds simple, but each structure has its own complexity. Resources has 6 numeric fields, which is straightforward. Planets have nested building arrays. Fleets contain ship lists and route planning data. Star systems recursively serialize their planet arrays. But the real beast was Sim Empire, which uses array lists, auto hash maps, and string hash maps. Getting all of those to properly serialize and deserialize took careful attention to Zig 0.15.1's allocator patterns. The serialization layer is wrapped in a Zig simulation class that provides 3 clean methods for GDScript: load galaxy, export galaxy, and run turn. The load method deserializes the entire galaxy state from GDScript into Zig memory. The export method serializes the results back, and run turn is the entry point for the full turn simulation, which is currently a placeholder but will soon contain all the game logic. To validate this work, I created a comprehensive test suite with 7 serialization tests. Every test performs round-trip conversion, GDScript to ZIG and back to GDScript, then verifies data integrity. All 7 tests passed, covering resources, empire, planet, system, fleet, and galaxy structures. I also fixed some issues with the Zig Resource Manager integration. I added a calculate upkeep from Empire method that returns a dictionary compatible with the GDScript resources class. This method is now properly registered in the bind methods function, so GDScript can call it directly. With those changes, all 4 Zig Resource Manager tests are now passing. There was also a fix needed in the test suite itself. Godot 4.4 has strict typed array constraints, and I was trying to directly assign an array of integers to a typed array field. The solution was to use the empire.addSystem method instead, which handles the type conversion properly. The performance numbers continue to look good. The Zig Resource Manager runs in 1.10 microseconds per call, compared to 1.68 microseconds for the GDScript version. That's a 1.53 times speedup, which isn't dramatic on its own. But remember, the whole point of this full simulation approach is to minimize boundary crossings. Once the entire turn runs in Zig with just one call from GDScript, we expect 20 to 50 times speedup. Yesterday, I also documented some critical bug fixes I made to the GDZig library earlier in the week. GZig is the code generator that creates Zig bindings for Godot's GD extension API. I hit 8 blocking bugs during the initial compilation attempts. The key fix was adding the string void to the type.string_map, which was causing void return types to fail. I also added Zig keyword escaping, fixed empty signal parameter names, and added a line cast for pointer alignment. With those fixes, the Stellar Throne Zig extensions now compile successfully into a 1.5 megabyte dynamic library. Let me give you the technical summary. Yesterday's work added 242 lines to the new test_zig_serialization.gd file. The Zig Resource Manager gained 55 lines for the new calculate upkeep method. I also fixed 8 lines in the existing Resource Manager unit tests. The GDZig documentation updates added 329 lines to the resume.md file explaining all the bug fixes. Across 5 commits, I touched 11 files and added or modified approximately 600 lines of code. This completes Step 2 of the Zig full simulation strategy. Step 1 was creating the 6 core data structures with 24 unit tests. Step 2 was the serialization layer with 7 serialization tests. Now I'm moving into Step 3, which is porting the remaining 14 managers to Zig. After that, Step 4 will integrate full turn coordination, and Step 5 will validate the 10 to 50 times performance improvement we're targeting. The system is now production ready in the sense that the Zig extensions compile cleanly and all tests pass. The serialization layer has been verified with round-trip conversions, meaning I can send data from GDScript to Zig, run computations, and get the results back without corruption. That's the foundation I needed before porting the actual game logic. To put this in context, Stellar Throne simulates galaxies with hundreds of star systems, dozens of empires, thousands of planets, and hundreds of ships. Running a full turn in GDScript currently takes long enough that it impacts the balancing tool's usability. The goal is to move that entire simulation into Zig, where it can run 20 to 50 times faster. Yesterday's work built the bridge that makes that possible. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.